quadratics by factoring. We have a perfect square trinomial for the first example, so I'm not going to do area diamond. I recognize that this is a perfect square, this is a perfect square, and if I were to guess what this is, it's in the form u squared minus 2uw plus w squared. So I'm going to use the template that I used for perfect square trinomials. This is going to factor into u minus w times u minus w. So that would give me x minus 7 times x minus 7. Now I'm trying to figure out what x is. So what would make this quantity 0? So x minus 7 equal to 0, add 7 to both sides, x would be 7. Now if I went a little fast on that, maybe review the video for perfect square trinomials, but if you want to check it, you could quickly just do an area model to check it. You don't have to go through the whole area diamond operation. These, when I add like terms, when I combine like terms, I get negative 14x. So you're factoring these and you're solving for x. Now in this case it was a perfect square trinomial. The next one may not be. The next example is not a perfect square trinomial. So it's good to look for those and save yourself some time. So square minus 11x plus 18. I'm going to do a quick area diamond. X squared and 18 go in opposite corners, so I'm looking for factors of 18x squared that add up to a negative 11x. So that's going to be 2x and 9x. When I multiply them, I get 18. When I add them, if they're both negative, I will get negative 11, and when I multiply them, I'll get positive 18. So this should be pretty routine at this point. So this is going to factor into x minus 2 times x minus 9 equals 0. So if I'm looking for x minus 2 equals 0, hopefully you've done zero product property and this makes sense. If this doesn't make sense, review the video for zero product property. So x minus 2 equals 0 would give me x equals 2. X minus 9 equals 0 would give me x equals 9. Okay, the next example I'm going to do is from just quadratics by factoring, not the intro. And just like difference of two squares, perfect squares, the intro didn't have a common factor, but the regular exercise did. This has a common factor of 2, so I'm going to divide all of these terms by 2. I'm going to take that 2 out, so that's going to give me 2 times x squared minus 14x plus 49. And I think I just did this example. So this factors into, this is why it's good to take notes, x minus 7 times x minus 7. So I'm going to skip the work for that and just write 2 times x minus 7 times x minus 7 equals 0. So I'm looking for x. X must be 7. If you're multiplying these terms and you're getting 0, then one of them's got to be 0 or they're all 0. In this case, you've got two that are identical, so x equals 7. The next example that pops up is 2x squared minus 2x minus 180. Again, I've got a common factor. I'm going to divide everything by 2, which would give me 2 times x squared is 2x squared. 2 times x is 2x, and that 2 is negative, or you can just think of it as a minus sign. And 2 times 90 is 180. Now here, I'm going to factor x squared minus x minus 90 using area diamond. So I'm looking for factors of negative 90x squared that add up to a negative 1x. So that's going to be 9x and 10x. I want the 1 to be negative, so I want the 10 to be negative. When I multiply, I get negative 90. When I add, I get negative 1. So this is 9x and negative 10x. So then this factors into x plus 9 times x minus 10. And if I'm multiplying these three quantities to get 0, one of them is 0 or two of them are 0. 2 is not equal to 0, so we don't need to worry about that. But x plus 9 must be 0, x minus 10 must be 0. And by the way, on the tests, we did not have any like this in class, but they give you one where this is x. So you could actually have a third factor where x equals 0. Hint, hint. If x plus 9 is 0, x equals negative 9. If x minus 10 is 0, x equals 10. And that should be enough to get you through this exercise.